Okay, here we go, section 2.5, Algebraic Proofs. We are going to review properties of equality, use them to write algebraic proofs, and identify properties of equality and congruence. Only vocab word we need to know is proof. So these proofs, okay, you hear a lot about proofs in geometry, and this is our intro into it. It's an argument that uses logic, definitions, properties, previously proven statements to show that a conclusion is true. Basically, it's explaining every single step and saying why we can do each step that we're doing in order to solve a problem. The important part of this is to give the justifications to show that it's valid. We need to know why we can say everything. So we're going to use properties today for algebra. Okay, these are algebraic proofs. We're going to use these properties. The first four you've used time and time again. All this is saying, really, and if I look over here at the addition property, this would be like when I have x minus 4 is equal to 10, and I want to solve that out. I do plus 4 plus 4. This right here, adding the same thing to both sides, that is the addition property of equality. Okay, that property of equality says I can add the same thing to both sides and it will remain equal. Okay, same thing with subtraction. I can subtract the same thing from both sides, it remains equal. Multiplication, I multiply both by the same thing and it's going to stay equal. Division, I divide both sides by the same thing and it stays equal. Okay, so we've used those first four before. Moving on to the next three, those kind of go together. Reflexive property, it's kind of a silly one. It's something is equal to itself, right? 4 is equal to 4. X is equal to X. A is equal to A. That is reflexive. You wouldn't think that we would use that a lot, but eventually we will be using that quite a bit when we get into geometric proofs. We've got symmetric property, just means I can flip around the two sides of the equal sign. So if I have x is equal to 5, that's the same exact thing as 5 is equal to x. So that's symmetric. Transitive property, if A is equal to B and B is equal to C, then A is equal to C. This is very, very similar to our law of syllogism that we just talked about the other day. If A is equal to B and B is equal to C, this B and this B are the same exact thing. So if A is equal to that and that's equal to C, then we can jump straight from A to C. Okay, that is our transitive property of equality. Very, very similar to the law of syllogism. The way that we're going to remember reflexive, symmetric, transitive, if you look, the reflexive property only has that one letter, right? It's got one statement. That's a 1. The symmetric property, there are two letters. There are two statements. That's a 2. For transitive property, I've got an A, I've got a B, and a C involved in there. There are 3 statements. That's a 3. So how we're going to remember this is RST123. RST123, reflexive, symmetric, and transitive. And then finally we have substitution property. Substitution just says we can replace something with something else as long as we know that they're equal. So if A is equal to B, wherever I see an A, I can put a B because they are equal. I can substitute that in. And then just a reminder of our distributive property. Right, our distributive property says I can multiply A times B and C and get AB plus AC. Okay, so we're going to solve this equation and we're going to write a justification for each step. First thing we have to write down is the original equation. That original equation that we write down, that is our given. So we would write given or given equation. The right side of our problem here is always going to be the justification. It's always going to be the reason. Why can we say the step that we just wrote? So the first thing we're going to do, and this is a two-step equation, you know how to solve this, we would add 8 to both sides. Well, when we're adding 8 to both sides, that is the addition property of equality. That's why we can do that. Our next line, we're just simplifying. We're taking that 4m, we're bringing it straight down, we're subtracting, or we're doing negative 12 plus 8 is negative 4. We are simplifying to get to that point. We got one more step here, got to divide by 4. When we divide both sides by 4, that is the division property of equality. And we just got to simplify to get our final answer. So you'll notice that where the work is shown, that is the property. Where we are getting the result after that work, that is simplify. So we are going to solve it and give a justification for each step. Okay, so you can go ahead and try this one out. Okay, should be pretty quick, only a couple steps here. Do the work, write the justifications, pause it, come on back, see if you got it right. Alright, so when we look at it, we've got our given equation, and then we are going to multiply. Remember, we multiply by the reciprocal, so we're multiplying both sides by 2, multiplication property of equality, and then it's just a matter of simplifying. Nice 3-step proof right there. Okay, so we can also use these algebraic proofs in geometry. We can talk about segment lengths and angle measures as numbers. So we're going to use these same properties when we're solving problems using some geometric stuff that we've already talked about. Just a reminder, helpful hint here, AB without the line over it represents the length of that segment. So we can think of AB as a variable represented. It's an x, right? It's just a variable. So it's not A times B, it's AB. That is the variable. When we look at this, we want to write a justification for each step. If we're trying to solve for x here, well, you should know by now that we can add 2x plus 3x minus 9 is equal to the whole big thing, which is 4x minus 4. But even before that, why can we say that? Well, we can say that because of the segment addition postulate. Segment addition postulate says I can add the two smaller segments together to equal the whole big segment. So notice that we write it first with the letters. Okay, we don't put the numbers in yet, the expressions in. We write it just with the letters. That is the segment addition postulate. From there, now we can substitute in what NM, MO, and NO are. So we are using substitution property of equality there to substitute that in. We're just going to simplify. We're combining like terms on that right side. Once we're here, now we're going to start moving stuff side to side. So now we're going to use those other properties of equality, so those first four. We are subtracting 4x from both sides. Now, I want you to notice they didn't show the work this time. They just showed the result of that. So this step is the result of subtracting 4x from both sides. So that is subtraction property of equality. We don't need to have a simplify step after that because we didn't show the work. We just have the result. So the result now is the subtraction property. From here we would add 9 to both sides, so we have addition property of equality. So notice that we didn't put in the work there. If we had put in the work where this was plus 9, then the addition property of equality would go with the work, and then the bottom one would be simplify. Since we don't have that work being shown, we don't have to put that simplify step in. It's just addition property of equality. Okay, so go ahead and try this one. Very, very similar, but we're not using segment addition postulate right now. So try it. Come on back. All right, so we got to set up our original, which is the measure of the angles using angle addition postulate. Then we can substitute in. We can combine like terms or simplify. We would subtract 9x, so that's subtraction property of equality. And then we would either multiply or divide by -1. So that last step could either be multiplication property of equality or division property of equality. Either way, we're going to get 11 for x. But make sure, just as important right now, are those justifications. Okay, so we've talked about before that segments with equal lengths are congruent, angles with equal measures are congruent. So reflexive, symmetric, and transitive properties of equality also have properties of congruence. We look at that, we have the same three, R, S, T, 1, 2, 3. Only now instead of an equal sign, we're seeing a congruent sign. So that's the only difference. It's the same exact thing, but we're using congruence. This reflexive property of congruence, we're going to use that all the time this year. All the time. Saying that something is congruent to itself. It sounds silly, but we are going to use it. You've got your symmetric, your transitive property, right? RST 1, 2, 3. And then just remember that numbers are equal, figures are congruent. So if you're talking about numbers, then we are using the equal sign, we're using properties of equality. If we're using the figures, angles, segments, those are congruent, so we're using properties of congruence. All we're trying to do here is identify which property is being used here. So A, that has just one thing in it, right? It's got one statement, that is R, reflexive. B has two statements in it, so that is symmetric. Notice that A was reflexive property of congruence because there was a congruency symbol. 2 is symmetric property of equality because there's an equal sign. 3's got that congruent symbol again. There's 3 of them, so we're looking at transitive property of congruence. And then of course D, equal sign, one set of things there, so we're looking at reflexive property of equality. Okay, try it again, see if you can get these. Okay, so we've got symmetric property of equality, reflexive property of equality, transitive property of equality, and then finally symmetric property of congruence. Good. We've got a couple questions for our lesson quiz here. Another algebraic proof that we're trying out. So pause it, try it, come on back with your steps. Alright, so we start with our given. We multiply both sides by 6, multiplication property of equality. We add the 5, there's your addition property of equality. Good. Remember, the answer isn't necessarily what we're looking for. We're looking for those steps as well. Next one more. Try it. Okay, first thing we have is the given. We distribute that -2. So that is the distributive property. That's why we did it. We added the 2r to both sides. We added the 3 to both sides, and then we divided by 8. So addition, addition, division for that. And again, remember, they're not showing the work. That's why it's okay to not have those simplified steps. If you're showing the work, the addition property needs to go with the work, and then the result is simplify. Okay, last one. Identify the properties. Pause it. Try it. Come on back. Alright, for 3, we've got transitive property of equality, reflexive property of congruence, and symmetric property of congruence. So make sure you know your properties. Make sure that you are writing your justifications down on the right side of that algebraic proof. We're going to get into some harder proofs in 2.6 and moving through the rest of the book, but that's it for section 2.5.